In this video, we are going to learn how to represent constant rates of change in this given table. Now let's go ahead and take a look. My first table here is representing time and water. Water seems to be represented as a dependent value of time, so potentially depending on how much time is given, the gallons of water will either increase or decrease. So let's go ahead and try to find the constant rate of change of these values. Now, when we do this, what we have to find out is we have to find the change of y values and then divide that by the change of x values. So let's go ahead and tackle the change in y values first. To go from a 51 and 2/10 to a 46 and 4/10, I noticed that this is going to be a subtraction. I'm not adding any numbers because my numbers are getting smaller, so I know I'm either subtracting or dividing. Now, because this is potentially a linear equation, I know that I'm likely going to be subtracting values. Let me go ahead and do some subtraction and see exactly what that amount is. Okay, so what we found here is that there is a change of 4 and 8/10. I am subtracting 4 and 8/10 to get to my next value. Let me go ahead and see if that change is the same for all these other values. All right, so what we have found is that there is a constant rate of change here of -4 and 8/10. So I'm going to write that next to my change of y. Now let's go ahead and find a change that is happening in your x values. To go from a 2 to a 4, my numbers are increasing, so I know it's going to either be multiplication or addition, and because this is a linear equation, I'm going to be adding a 2. And that is actually what I am finding between 6 and 8. That's also adding a 2. And this is the constant rate of change in between x values. So I'm going to be adding a 2. Now I'm going to go ahead and simplify this and divide 4/8 by 2. Knowing that this is going to give me a negative quotient, I'm going to write my negative sign first before I begin dividing. All right, and when I'm done dividing, my quotient is -2/4. So my constant rate of change in this case is a -2 and 4/10. Now I can apply this to begin writing a rule. If I were to plug in some of these values, I'm going to go ahead and plug in 32 for y and 10 for x. What I notice that I don't have equal numbers on each side. So I know that these values don't work for the rule that I wrote. So I have to modify my rule. Now I notice that -24 here is actually 24 points away from a 0. And then 32 points away from 32. So if I add these two together, that'll give me the total distance of what I'm missing here from a -24 to a 32. I can go ahead and add that distance to my rule. So that's a distance of 56 points. If I add that, then that could potentially be the correct rule to represent this table. Now let's go ahead and plug in some numbers just to make sure that that works. I'm going to plug in 51 and 2/10 for y and 2 for x. And if I do the math, this should work out where one side is exactly equal to the other side. What we found is that 51 and 2/10, when we do the math, is going to be equal to 51 and 2/10. So both sides are going to give me equal values. That means that this is the correct rule. You can use the constant rate of change to determine the unit rate from a table, but also begin writing a rule. Now go ahead and try to work on this next table, trying to find the constant rate of change, and try to write a rule with that constant rate of change.